Near the Sun, a small planet hides big secrets. Mercury, small and hot, has fooled us for years. But now, space probes have discovered strange surprises. They seem to have found diamonds on the hottest planet in our solar system. And that's just the beginning. What we thought about Mercury's interior is completely wrong. There are some very big and very strange secrets there. Why is Mercury so different from the other planets? And what other secrets is it hiding? That's exactly what we'll explore in this video, so stay tuned until the end to not miss a single detail. But before we start, be sure to like this video and subscribe to the channel. Exploring the terrain. Mercury, the smallest planet in our solar system, has long been a source of fascination for astronomers and space enthusiasts. Its mysterious landscape, hidden from our perception for centuries, began to reveal its secrets only when space exploration significantly advanced. The journey to uncover Mercury's enigmatic terrain began with NASA's Mariner 10 mission in 1973 and continued with the Messenger probe in 2004. Mariner 10, the first spacecraft to visit Mercury, provided us with our first close-up look at this elusive world. During its flybys, it captured images showing a landscape filled with craters and strange slopes, much like our moon. This mission revealed that Mercury had a rugged, crater-filled surface, along with a surprisingly strong magnetic field and a larger-than-expected core. These discoveries challenged scientists' assumptions about Mercury's composition. The Messenger mission, an acronym for Mercury Surface, Space Environment, Geochemistry, and Ranking, launched 31 years after Mariner 10, took our understanding of Mercury to new heights. Unlike its predecessor, Messenger was designed to enter Mercury's orbit, allowing for a more comprehensive study of the planet. During its mission, Messenger took an impressive 200,000 photographs, revealing areas of Mercury never seen before. One of Messenger's most intriguing discoveries was the strangely high levels of calcium and magnesium on the planet's dark side. This raised questions about the processes that could lead to such concentrations. Additionally, the mission found that Mercury's magnetic field was exceptionally strong in the northern regions, which is unexpected compared to other planets. These findings led scientists to realize that Mercury's internal structure and formation process were very different from what they initially thought. In most planets, like Earth, magnetic fields are created by the movement of liquid iron in the core. However, Mercury's peculiar internal structure results in different magnetic behavior. But what makes Mercury's terrain truly stand out? It's not just the craters and slopes, but also the extreme conditions on its surface. During the day, temperatures on Mercury can reach a scorching 800 degrees, 430 degrees, hot enough to melt lead. At night, they plummet to freezing, 290 degrees, 180 degrees. This extreme temperature fluctuation is due to Mercury's thin exosphere, which barely regulates temperature or retains heat. Despite these harsh conditions, recent studies have uncovered some surprising features on Mercury's surface. In 2012, data from Messenger revealed evidence of volcanic activity, including pyroclastic deposits from explosive volcanism. This discovery challenged the long-held belief that Mercury was geologically inactive. Even more intriguing, in 2020, scientists announced the discovery of frozen water in some of Mercury's polar craters. These permanently shadowed regions are cold enough to preserve frozen water, even on a planet so close to the Sun. This finding raised new questions about the potential for simple life forms to exist on Mercury. Could there be extremophiles, like the organisms found in Earth's extreme environments, living in these icy refuges on Mercury? The most recent mission to Mercury, Bepi Colombo, launched in 2018 as a joint effort between the European Space Agency and the Japan Aerospace Exploration Agency, is scheduled to arrive at Mercury in 2025. This mission promises to provide even more detailed information about Mercury's surface, including its chemical composition and geological history. From its unexpectedly strong magnetic field to the presence of frozen water, Mercury continues to surprise us. But what we're going to explore next will truly amaze you. After all, how can a planet so close to the Sun have years shorter than a day? A year shorter than a day. When we think of planets, we usually imagine them spinning on their axis once a day and orbiting the Sun over the course of a year. But Mercury breaks this pattern in a fascinating way. On this small, sun-scorched world, a year is actually shorter than a day. Let's see how this works. Mercury takes only 88 Earth days to complete one orbit around the Sun. This quick journey makes a Mercurian year much shorter than ours. But here's where it gets really interesting. A single day on Mercury, meaning a complete rotation on its axis, takes an astounding 176 Earth days. This means that on Mercury, a year lasts only half a day. This unusual situation has some truly bizarre effects. If you were standing on Mercury's surface, you would see the sun rise and then gradually grow in the sky as it moves slowly across the heavens. Then, the sun would seem to pause and start moving backward for a while, retracing its path. This strange dance happens because Mercury's rotation can't keep up with its rapid orbit. But why does Mercury spin so slowly? Scientists believe it's due to something called tidal locking. Over billions of years, the sun's gravitational pull slowed Mercury's rotation. However, unlike our moon, which is fully tidally locked to Earth, Mercury is affected by what we call a 3.2 orbital resonance. This means it spins 3 times for every 2 orbits around the sun. The effects of this unusual day-night cycle on Mercury's surface are extreme. The side facing the sun burns under intense heat for months on end, while the night side remains in frigid darkness for an equally long period. This leads to some of the most extreme temperature variations in the solar system. And regarding Mercury's atmosphere, or lack thereof, it's important to note that the thin atmosphere it does have is called an exosphere. This incredibly thin layer of gases is constantly being lost to space and replenished by various processes. Solar wind, radioactive decay, and even micrometeorite impacts all contribute to maintaining Mercury's thin exosphere. Recent observations have revealed some surprising components of this exosphere. In 2020, researchers used data from the Messenger spacecraft to discover that Mercury's exosphere contains more water vapor than previously thought. This vapor is believed to form when hydrogen from the solar wind combines with oxygen in surface rocks. Another fascinating aspect of Mercury's short year and long days is how this affects the planet's magnetic field. Despite its small size and slow rotation, Mercury has a global magnetic field, which surprised scientists when it was first discovered. Recent studies suggest that Mercury's magnetic field is generated by a peculiar dynamo effect in its liquid metal core, something driven by the unique characteristics of the planet's orbit and rotation. This magnetic field, though much weaker than Earth's, plays a crucial role in protecting Mercury's surface from the strong solar winds. Without it, the solar wind would quickly strip away Mercury's thin atmosphere. The combination of a rapid orbit and slow rotation also leads to some interesting observational possibilities. There are specific points on Mercury's surface called hot poles, where the sun appears stationary in the sky at certain times. These hot poles are where the planet's heat reaches its most extreme point. Conversely, there are areas near Mercury's poles that never receive sunlight. These permanently shadowed regions are where scientists found evidence of frozen water. But how can ice exist on a planet so close to the sun? This happens due to Mercury's unique orbit and rotation. Permanently shadowed craters near the poles never receive direct sunlight, staying incredibly cold even when nearby areas warm up in the sun's heat. This discovery has led scientists to wonder, could there be other volatile substances, like organic compounds, preserved in these cold regions? Mercury's short year and long day also affect how we study the planet. Because Mercury orbits the sun quickly, it's challenging for spacecraft to reach it. They must use complex maneuvers, including multiple flybys of Venus and Mercury itself, to slow down enough to enter orbit around the planet. The Bepi-Colombo mission, currently en route to Mercury, will use these gravitational assists to gradually adjust its speed and trajectory. Having launched in 2018, the spacecraft won't enter orbit around Mercury until 2025, after completing 9 planetary flybys. Once in orbit, Bepi-Colombo will face another challenge related to Mercury's unusual day-night cycle. It will need to carefully manage its exposure to the intense heat on the day side while maintaining power during the long, cold nights. This delicate balance is crucial for the mission's success and highlights the extreme conditions created by Mercury's unique rotation and orbit. Recent computer simulations have provided new insights into how Mercury reached its current rotation rate. These models suggest that Mercury may have spun much faster in the past but slowed down due to the combined effects of the sun's gravity and impacts from large asteroids and comets. This research helps us understand not only Mercury's history, but also how other planets in the solar system may have evolved. As we continue to study Mercury, more questions arise. How does the planet's core remain partially liquid despite long nights and extreme cold? What role does Mercury's unusual orbit play in shaping its geology? These questions remind us that even in our own solar system, many mysteries remain to be discovered. Mercury's unique characteristics challenge our understanding of how planets form and evolve, pushing us to expand our theories and explore new possibilities. So, what other secrets might Mercury be hiding beneath its cratered surface? A small planet with many incredible secrets. Mercury, the smallest planet in our solar system, holds a surprising number of mysteries within its tiny size. Despite being small, Mercury continues to baffle scientists with its unique and unexpected features. One of the most intriguing secrets of Mercury is its unusually large core. Dr. Nancy Chabot, a planetary scientist at Johns Hopkins University's Applied Physics Laboratory, led a study that revealed Mercury's core makes up about 85% of the planet's total volume. This is significantly larger than Earth's core, which makes up only about 15% of its volume. But why does Mercury have such a large core? One theory suggests that Mercury may have been a much larger planet that lost most of its outer layers in a massive collision early in the solar system's history. This idea was proposed by Dr. Eric Asfog from the University of Arizona. According to this theory, a large celestial body may have struck Mercury, stripping away much of its mantle and crust, and leaving behind the iron-rich core we see today. Another incredible secret of Mercury is its unexpected magnetic field. Unlike Venus and Mars, which lack global magnetic fields, Mercury generates a magnetic field that is about 1% the strength of Earth's. This discovery, made by NASA's Messenger mission, intrigued scientists because they didn't expect such a small and slowly rotating planet to maintain a magnetic dynamo. Dr. Katherine Johnson, a planetary scientist at the University of British Columbia, led a team that found something even more surprising about Mercury's magnetic field. They discovered that the magnetic field is offset from the planet's center by about 20% of Mercury's radius. This difference may be due to variations in the planet's crust thickness that affect how heat flows from its interior. But the mysteries don't stop there. In 2020, scientists announced the discovery of volatile elements on Mercury's surface, including sulfur, potassium, and sodium. These elements typically evaporate quickly at high temperatures, so finding them on a planet so close to the Sun was unexpected. Dr. Patrick Poplawski of Johns Hopkins University's Applied Physics Laboratory suggested that these volatile elements may have arrived on Mercury via comets or asteroids after the planet's formation. One of the most exciting recent discoveries about Mercury is the presence of frozen water in permanently shadowed craters near its poles. Dr. Nancy Chabot, whom we mentioned earlier, was also involved in this research. The ice was found despite Mercury's proximity to the Sun because these craters never receive direct sunlight, keeping the temperatures extremely low. But here's where it gets even more interesting. Besides frozen water, scientists found evidence of organic compounds in these same craters. These dark deposits may be complex carbon-based molecules similar to those that could have played a role in the origin of life on Earth. Could Mercury, despite its harsh conditions, hold clues to the origin of life in our solar system? Another incredible secret of Mercury is its unexpected geological activity. For years, scientists believed that Mercury was a geologically inactive world. However, data from the Messenger mission revealed evidence of relatively recent volcanic activity. Dr. David Rothery from the Open University in the UK identified small, bright spots on Mercury's surface that appear to be volcanic vents. These features suggest that Mercury might still be geologically active today. One of the most intriguing features of Mercury is its chaotic terrain, a vast area of hills and valleys near the planet's south pole. This region, first observed by the Mariner 10 mission in the 1970s, covers an area roughly the size of the U.S. state of Texas. Dr. Thomas Waters from the Smithsonian Institution proposed that this terrain may have been formed by massive quakes caused by the Sun's gravitational pull as Mercury's orbit evolved. Recent studies have also revealed surprising details about Mercury's composition. Dr. Amir Khan from the University of Zurich used data from the Messenger mission to study the planet's internal structure. His team found that Mercury's core likely consists of a liquid outer layer and a solid inner core similar to Earth's. However, Mercury's inner core is proportionally much larger than Earth's, which could explain some of the planet's curious magnetic properties. These incredible secrets of Mercury challenge our understanding of planetary formation and evolution. They remind us that even in our cosmic neighborhood, many mysteries remain to be solved. As we look forward to future missions and discoveries, we can't help but wonder, what other surprises might be hidden beneath Mercury's cratered surface? The hidden depths of Mercury. Recent discoveries and ongoing missions reveal that Mercury's subsurface holds secrets as fascinating as its visible features. One of the most interesting aspects of Mercury's hidden depths is the structure of its core. Unlike Earth, which has a solid inner core surrounded by a liquid outer core, Mercury's core is mostly liquid with a solid inner portion. This unusual central composition was confirmed by NASA's MESSENGER mission, which used subtle variations in Mercury's gravitational field to map its internal structure. It's estimated that Mercury's solid inner core is about 1,140 miles, 2,000 kilometers wide, making up nearly half of the planet's entire core. This is proportionally much larger than Earth's inner core, which makes up only about 20% of its volume. The size and state of Mercury's core play a crucial role in generating its magnetic field, which is much weaker than Earth's but still surprisingly strong for such a small planet. Beneath Mercury's crust lies a thinner mantle than previously thought. Recent studies suggest that Mercury's mantle may be only about 260 miles, 420 kilometers thick, compared to Earth's mantle, which is about 1,800 miles, 2,900 kilometers thick. This thin mantle has implications for Mercury's geological activity and heat distribution. One of the most exciting discoveries about the planet's subsurface occurred in 2012, when MESSENGER detected evidence of ancient volcanic activity. The spacecraft found unusual shallow depressions that appear to have formed when volatile elements sublimated at the surface. These hollows suggest that Mercury's interior once contained more volatile elements than scientists previously believed. In 2020, researchers made another groundbreaking discovery about Mercury's subsurface using MESSENGER data. They found evidence of a vast underground reservoir of magma that existed in the planet's distant past. This ancient magma ocean likely played a key role in shaping Mercury's surface and internal structure. The presence of this ancient magma ocean could explain some of the planet's unique surface features, such as the vast smooth plains that cover much of the northern hemisphere. These plains, known as the northern volcanic plains, are believed to be the result of massive lava flows that occurred early in the planet's formation. But perhaps the most surprising discovery about Mercury's subsurface came in 2022. Researchers analyzing MESSENGER data found evidence of nitrogen trapped below the surface. This nitrogen may be the remnant of an ancient atmosphere that was driven underground by the intense heat and solar radiation that bombard the planet. The presence of nitrogen in the subsurface raises intriguing questions about Mercury's past. Did it once have a more substantial atmosphere? If so, what implications might this have had for its climate and potential habitability? Another fascinating aspect of Mercury's hidden depths is the presence of frozen water in permanently shadowed craters near its poles. While this ice is technically on the surface, it is shielded from direct sunlight and protected by the extreme cold in these permanently shaded regions. Recent studies suggest that some of this ice may be relatively new, possibly deposited by comets or asteroids in the last tens of millions of years. In addition to water ice, these polar craters also contain dark deposits that scientists believe may be organic compounds. These compounds, which appear to be more volatile than water, could be remnants of comets or asteroids that impacted Mercury. The preservation of these organic materials in the subsurface offers a unique opportunity to study the distribution of organic compounds in the inner regions of the solar system. Mercury's subsurface also contains clues about its geological history. Unlike Earth, the planet has no tectonic plates, but it shows evidence of significant stresses as it cooled over time. These stresses resulted in numerous thrust faults, where some parts of the crust were pushed over others. These geological faults, which can be several miles high, reveal the composition of Mercury's subsurface and its geological history. Recent analyses of these faults have revealed something unexpected. Mercury may still be tectonically active. A 2019 study found small features called tectonic pits associated with some of Mercury's larger faults. These pits, essentially small valleys formed by crustal extension, appear to be geologically young, suggesting that Mercury's crust is still moving and settling. One of the most mysterious features of Mercury's subsurface is the planet's magnetic field. Unlike Earth's magnetic field, which is generated by the movement of molten iron in its outer core, Mercury's magnetic field is believed to be produced by a different mechanism. Some scientists propose that it may be generated by a dynamo effect in a thin outer layer of liquid metal surrounding a solid inner core. Another strange aspect of Mercury's hidden depths is the possibility of underground faults that could provide pathways for heat and potentially even fluids to move through the planet's crust. Although Mercury's surface is completely dry today, some scientists speculate that there could be pockets of liquid water deep within its subsurface, kept liquid by residual heat from the planet's core. The idea of subsurface water on Mercury might seem far-fetched, but similar phenomena have been observed on other seemingly inhospitable worlds in our solar system. For example, Jupiter's moon Europa and Saturn's moon Enceladus have subsurface oceans beneath their icy crusts. And while Mercury's environment is very different, the possibility of underground water cannot be entirely ruled out. As we continue to explore the hidden depths of this planet, new questions arise. How has Mercury's internal structure evolved over time? Could there be other elements or volatile compounds trapped beneath its surface? And perhaps most intriguingly, what can Mercury's subsurface tell us about the early history of our solar system and the processes that shaped the planets closest to the Sun? These questions highlight the importance of continuing to study this planet. Every new discovery about its hidden depths not only enhances our understanding of this fascinating world, but also provides valuable insights into planetary formation and evolution throughout the solar system. As we await future missions and discoveries, one thing is certain: Mercury, despite its small size and proximity to the Sun, still has many secrets to reveal. Its hidden depths contain clues to its past and, perhaps, to the history of the entire solar system. Well, that's all for today. Let us know what you think we might find on Mercury in the near future. Could it be precious stones, or even extraterrestrial life? If you enjoyed this video, don't forget to like and subscribe to the channel. Thanks for watching, and see you next time.